Question number 6 is, if 2 log x equal to 4 log 3, then x is equal to what? A option is 3, B is 9, C is 2 and D is none of these. Now we know that log of m raised to the power n to the base a is n log m to the base a. We know this because when the power of m is n, then it comes in the product form of log m to the base a. Power here is n, so it will be multiplied by log m to the base a. Now with this rule, if I am to write the left hand side of it, so left hand side will be log of x square. This 2 will become power of x. So left hand side will be log of x square. What will be my right hand side? It is 4 which is being multiplied by log 3. So 4 will become the power of 3. So right hand side will be log 3 raised to the power 4. Now log is there both the sides. So x square will be equal to 3 raised to the power 4. X square will be equal to 3 raised to the power 4, which gives me that x is equal to 3 to the power 2, which is 9. I have taken square root both the sides. So square root of x square is x, 3 to the power 4, square root is 3 to the power 2, which is 9. So value of x is 9. That is our option B is correct answer. Now we will see question number 7. Question number 7 is that log of 64 to the base under root 2 is equal to, option A is 12, B is 6, C is 1, D is none of these. We assume that log of 64 to the base under root 2 is x. As we have seen in previous questions, we take that log of 64 base under root 2 is x. Now with the definition of log, under root 2 raised to the power x will be 64. And we know that under root 2 is 2 raised to the power 1 upon 2. So left hand side will be 2 raised to the power 1 upon 2 into x. And 64, we know this is 2 raised to the power 6. So on left hand side and right hand side, both we find that the base is 2. Now the powers will be equal. So 1 upon 2 into x will be equal to 6. 1 upon 2 will be multiplied by the x. So gives us 1 upon 2 into x on left hand side. Right hand side the power is 6. This gives us x is equal to 6 into 2, that is 12. So our option A is correct. Log of 64 to the base under root 2 is equal to 12. Question number 8 is log of 1728 to the base 2 under root 3 is equal to, options are 2 under root 3, B is 2, C is 6 and D is none of these. Now we assume that log of 1728 to the base 2 root 3 as x. So with the definition of log, 2 root 3 raised to the power x will be equal to 1728, as we have done in previous questions. With the definition of log, this base 2 under root 3 will become the base of the indices. Now we are to factorize this 1728. So for that, we know that 1728 is even, so it will be divided by 2. This gives us 864. Again we divide it by 2, we get 432. We again divide it by 2, So we get 216. Again we divide it by 2. We get 108. We again can divide it by 2. We get 54. And we again divide it by 2. We get 27. 27 is divisible by 3. We obtain 9. And 9 when divided by 3 gives us 3. And 3 divided by 3 gives us 1. So 1728 can be written as 2 raised to the power 1, 2, 3, 4, 5, 6. 2 raised to the power 6 into 3 raised to the power 1, 2, 3. 3 raised to the power 3. 1728 may be written as 2 raised to the power 6 into 3 raised to the power 3. Now see the left hand side. Left hand side will be 2 raised to the power x into, since root 3 can be written as 3 raised to the power 1 upon 2, so it will be 3 raised to the power x upon 2. 3 raised to the power x upon 2. Power of 3, which is 1 upon 2, will be multiplied by x, so it will be 3 raised to the power x upon 2. Now we can compare the powers of 2 both the sides, which gives us x is equal to 3, x is equal to 6, and when we compare the powers of 3 of both the sides, we get x upon 2 as 3, which again gives us x is equal to 6. So the value of x when compared both the sides of powers 2 and 3 respectively, we obtain x as 6. So what is x? X is the log of 1728 to the base under root 3. So we obtain its value as 6. So our option C is the correct option. Question number 9 is that log of 1 upon 81 to the base 9 is equal to. Options are 2, 1 by 2, minus 2 and none of these. Now we are to find here log of 1 by 81 to the base 9. Again, as we have seen in the previous question, we assume this as x. So with the definition of log, this will be 9 to the power x is 1 by 81. 9 here is the base of log, so 9 will become the base of the indices. 9 raised to the power x is 1 by 81. Now 1 by 81 can be written as 1 by 9 raised to the power 2, because 81 is 9 to the power 2, and with the rules of indices it can be written as 9 to the power minus 2. Now when we compare these two, both the sides we have 9 as the base, so powers will be equal. Therefore x will be equal to minus 2. Therefore x will be equal to minus 2, and hence our option C here is the correct. A simple question which is based on the definition of log. Question number 10 is log of 0.0625 to the base 2 is equal to. Options given are 4, 5, 1 and D option is none of these. Now we are to find here the value of log 0.0625 to the base 2. We take this value as x. So we are to find the value of x here. Now with the definition of log, 2 raised to the power x is 0.0625. Now when we remove this decimal number when we convert this decimal number in the fraction form, we are to write it as 625. We remove decimal, write 1 in place of it. Now decimal, after decimal we have 4 digits, so 4 zeros will come. This will be fractional form of this decimal number. Now we can cancel it by 25 and here when we divide 10,000 by 25 we get 400. Again 25, when we divide by 25 we get 1, and when we divide 400 by 25 we get 16. So 2 raised to the power x is 1 upon 16. Now 1 upon 16 can be written as 1 upon 2 raised to the power 4, which is equal to 2 raised to the power minus 4. Therefore, when we compare both the sides, 2 raised to the power x is 2 raised to the power minus 4. Base both the sides is 2. So powers will be equal. X will be equal to minus 4. Hence, our option, none of these is correct. The value of log 0.0625 to the base 2 is minus 4, which here is none of these.